Hello everyone. Today I'm gonna record homework 1.4-7. Here we can see the graph of the homework. This corner column of concrete, and the problem is asking us to calculate the stress applied on the column by a load of 3,500 kips. Okay, in order to do that, we calculate the area. As you can see at the bottom of this, the area has been separated as 44 times 44 inches, which would be the area of the whole square, minus the area of area 6, which would be 20 times 20, minus the area of the circle, which would be pi 10 inches squared to the over 4 using the diameter, and minus the area of the triangle, which would be 1/2 of 8 times 8. Okay, perfect. Now, calculating all of these, we find that the cross-sectional area of the column would be 1,425.46 inches square. Why is it important to calculate the area? Because, as we know, the stress is the load over the area where it's applied. And if we imagine a force going inwards in the plate, because this is the cross-sectional area of the column, going inwards in the column, right? Or if we can shift this column to a 3D view, right, and the load is going down, right, it's going to be applied in all of the area that is not that corner triangle, that circle, or that square A6. Okay, so now, as I said, this is the formula of the stress, and we divide the load 3,500 kips divided by the cross-sectional area, and we find that the average compressive stress of the concrete would be 2.46 KSI. The question also asks us about the centroid of the column. In order to calculate the centroid of the column, we need to use these two formulas for the centroid. These formulas would be expressed as the sum of the x-coordinates, as we can see, of the x-coordinates of each of the areas divided by the total area to calculate the x-coordinate of the centroid. The sum of the y-coordinates of each of the areas multiplied by each of these small areas divided by the total area to calculate the y-coordinate of the centroid. Let's see it in action. Okay. Alright. So to calculate the x-coordinate, we do 12, which would be the x-coordinate of area 1. Let's go back to the graph. Area 1, the x-coordinate of these would be half of this distance, which would be 12 inches, times the area 1, which would be 20 times 24. And that's what we have here. Now, this 12 times 24 times 24 is for area 2. That would be this square. The x-coordinate would be 12 because that distance is 24, and the area would be 24 times 24. Now, area 3 has an x-coordinate of 24 plus 10 because it would be half of this distance, so in total would be 34, and that's what we can see in this formula. 34, the x-coordinate of area 3, times 20 times 24, the area, minus the area of the triangle and the area of the circle. The x-coordinate of the center of that triangle would be 8/3 because this side in the x direction is 8 inches, and as we know, the center of the triangle is 1/3 of the height. Now 32 is the area of the triangle. That's why we multiply it by the area. And here 13 times pi times 5 squared would be 13 inches, 8 plus 5, as we can see in this graph, times the area using the radius. And we divide all of that by the total area, which would be the 3 initial areas minus the 2 areas that we subtracted. Making the calculations, we find that the coordinate for that centroid would be 19.56 inches. From this point that we are setting up as the origin of coordinates, as we can see, this is the x-axis and this is the y-axis, and the origin of coordinates would be this. So 19.5 inches, so around here would be the center of the shape, actually around this point, kind of like there where my mouse cursor is. Okay, we know that the area is symmetrical, so if we calculate the same for the y, we're gonna find out that the coordinate for the y is the same as the coordinate for the x, and obviously it's gonna be in this dashed line 45 degrees from this area, from the origin of coordinates. So about here is gonna be the centroid. So now we calculated the stress in the concrete column and also the centroid of that concrete column cross-section area. Thank you for listening to this video. Hope you have a good day. Bye.